So maybe we can start as they come in, so we can move on to the rundown accordingly. They're coming in slowly. Is it okay, Professor, if we start?
Yes.
Okay. All right.
Okay.
So I would like to introduce you first, Professor, to the students before we move on to actual lecture. So good afternoon, everyone. Thank you for joining us this afternoon in our course, Textile Craft 1, Fashion Research. And for today, we have a very special guest who will be filling in our lecture today with a very interesting topic on clothing and health. And it will be about protection today, and tomorrow it will be about prevention. We are very honored and very happy to have Professor Ji-Young Lee with us today from the Comfort Lab at Seoul National University. And she will be here today and tomorrow. And on the 24th, there will be member of the Comfort Lab who will be joining us to give a lecture as well. And so I will be introducing Professor Ji-Young Lee to our students who have joined us today. Professor Ji-Young Lee is currently the director of Comfort Lab at Seoul National University. She is a professor of the Department of Clothing at Seoul National University, the College of Life Sciences. And she is also currently the advisory member of the Logistics Subcommittee of the Policy Advisory Committee, the Ministry of National Defense. And she is also currently the Deputy Director of Graphene Research Center for Convergence Technology at the Advanced Institute of Convergence Technology, and she currently is on the editorial board of several journals, including Fashion and Textiles, Journal of Physiological Anthropology, and also Journal of the Human Environment System. She previously was a visiting professor at the University of Ottawa in Canada of the Faculty of Health Sciences, and she previously was also a postdoctoral fellow at Kyushu University in Japan and also the University of Minnesota, USA. And so we're very honored and very glad to have you today, Professor. Of course, I need to introduce my name. I'm Sabrina. I was the person who is in charge of the correspondence with you, and it's been a great time to finally to be corresponding with you and finally meeting you face to face, to put a face to the name. And so today we'll have you filling in and sharing with us the material that you've prepared for us, clothing and health, which is a very interesting point of view because we here at the Faculty of Art and Design, we learn about clothing, but from the aesthetic point of view, and we don't often talk about the more functional parts of clothing. And so this is a new point of view for us and also for our students to see how far the function of not just the clothing itself, but also the human body can affect what we wear and how we wear it. So Professor, I will be handing over the screen to you if you're ready, whenever you're ready.
Okay, I'm ready. Professor Sabrina, thank you for your kind introduction. And good afternoon, everyone. I'm very pleased to have this opportunity lecture to undergraduate students of the Textile Craft Studio. Today and tomorrow, I'm going to talk about my research area in terms of clothing and health, which is characterized by two keywords, protection and prevention. Today, protection will be the main subject, and tomorrow, prevention will be the main topic. Before moving to the main topic, I'd like to introduce my research history and my laboratory. I have received my PS, MS, and PhD at the Department of Clothing and Textiles in Seoul National University, Korea. In 2006, I started my postdoctoral research at the Department of Integrative Biology and Physiology at the University of Minnesota, USA. For the 2 years, I was involved in the NASA spacesuit research. From 2008 to 2011, I have did research at the Department of Human Science Environmental Ergonomics Laboratory in Japan. During those 4 years at Kyushu University, I was really fortunate to have many opportunities to participate in governmental research, especially on the occupational safety of workers, along with thermal adaptation studies. Since 2012, I have been a professor at my university here, and now I'm running my laboratory named Comfort Laboratory. I'd like to explain why I could coin the name of my laboratory as a Comfort Lab. The term comfort is an acronym of clothing and omnicare for thermal regulations. If anyone who is interested in my laboratory, you can click the link here. We do research on thermal adaptation or thermal acclimatization and personal protective equipment, PPE, sportswear, or sleeping and bathing environments. The common interest among those research areas is body temperature regulations. So what is a body temperature regulations? This schematic diagram describes a feed-forward and negative feedback mode in body temperature regulations. Let's say it is now the middle of summer. Environmental heat stress stimulates thermal receptors on the skin. The thermal signals from the skin are delivered to the preoptic area of the brain. The thermoregulatory center of the brain activates effector mechanisms such as sweating or vasodilations. Through the sweating and vasodilations, body heat loss increase under heat stress. Finally, body temperature achieved homeostasis. Furthermore, we are interested in body temperature regulations of workers who should wear personal protective clothing. Work includes protection from natural disasters, industrial accident, firefighting, war or terror, heat waves, the deep sea, and space. Let's move to the first main topic, main keyword of clothing and health protection. Some of you may be curious about what a research pyramid is. In general, research on personal protective equipment follows the 5 steps as described in this pyramid. The first step is to test physical properties of PPE materials, fabrics, or fibers, such as tensile strength, tear strength, air permeability, moisture permeability, heat resistance, etc. At the same time, the occupational monitoring of workers should be carried out. These are basic and fundamental. The second step is to test thermal insulation or water vapor resistance using thermal mannequin, and if necessary, skin burn areas of flame retardant PPE can be estimated using flame mannequins. The mannequin test is considered as an intermediate stage between textile test and a human wear trial. In fact, because of clothing is worn three-dimensionally over the human body, not two-dimensionally, the mannequin tests are very, very effective for testing the effects of air layers inside the PPE. The third step is a human wear trial. To be honest, this is my laboratory's expertise. We recruit human subjects and evaluate physiological and subjective responses of human subjects while wearing PPE in a climate chamber. This stage is very important in terms of reflecting the reliable responses of human beings. The first step is a field test where the PPE is worn. Many mobility tests are conducted based on particular postures and motion protocols. The last step is to suggest the test method or guidelines for the PPE and workers. I'd like to explain the first step, first stage more specifically. Occupational monitoring includes the following three items: thermal environment monitoring and physiological monitoring, and focus group interviews or surveys. These are photos which were taken while we were monitoring cucumber greenhouse in summer, red pepper harvest, and pesticide spraying in summer, and railroad maintenance in Korea, and in a nuclear facility workers in Japan. Let's move on to the second stage of PPE research, thermal and flame mannequin test. The thermal insulation of clothing means thermal resistance of clothing, but the units differ from each other. When we express thermal insulation of clothing, the unit is kilo, while Kelvin and square meter per watt. The 1 kilo corresponds to 0.155. So we define 1 kilo as a thermal insulation of clothing, which maintains mean skin temperature at 33 degrees Celsius with the energy expenditure of 58 watt per square meter at the air temperature of 21 degrees Celsius and air humidity of 50% relative humidity. Subject should feel thermally comfortable at rest. Here it means IT means total thermal insulation of clothing. Let me explain the concept in more detail here. So according to ISO 9920, total insulation is thermal insulation from the body surface to the environment, including all clothing, includes the air layers and the boundary air layer. This schematic diagram represents the total basic and air insulation. Let's say the number four is human body, and the line, this curved line, is the skin of the body. The number 3 in black is the clothing layer enclosing the human body, and number 2 here is an air layer enclosed by clothing, and number 1 here is the boundary air layer of the clothing. Here, capital IT, total insulation is the sum of the number 1, number 2, and number 3. ICL here, basic insulation, is the sum of number 2 and number 3. IA here, air insulation, is the insulation of the boundary air, number 1. So when we operate a thermal mannequin, we can measure IA, air insulation, and IT, total insulation, not ICL. We cannot measure ICL using the thermal mannequin. ICL is a subtraction of IA from IT. That is, we cannot measure the thermal insulation of the number 3, clothing itself. And we have to remember all clothings are the sum of the number 2 and number 3. Okay. The first thermal mannequin appeared in 1945 by the US Army. That was one segment mannequin. So for the past centuries, the technology improved more and more. At present, we use this kind of mannequin with 20 to 30 segments. This slide shows the thermal insulation of military uniforms with different water repellent finishes. Our expectation at that experiment was that military uniforms with water repellent finishing would show greater thermal insulation than that of the current military uniform. But interestingly, type T is water repellent finishing uniforms resulted in smaller thermal insulation than the current original military uniform. So which is suggest not smaller, the same, which is suggest that it is possible to develop an advanced military uniforms with both water repellent finishing and thermal comfort functions. Recently we have tested thermal insulation of healthcare workers, PPE, during the COVID-19 pandemics. Following a focus group interview with the medical doctors and nurses in the line of duties, a total of 6 PPE ensembles were selected. Starting from the least protective PPE ensemble to the most protective PPE ensembles. So we compared the thermal insulation and water vapor resistance using the thermal mannequin. Furthermore, the wearable technologies are applied to various PPE. Especially cold protective clothing is often equipped with active heating systems. And we tested the thermal insulation of life jackets with active heating units on the chest and the upper back. And these life jackets very effectively conserve the body heat of fishermen who are shipwrecked in winter. Speaking of cold protective clothing, padded long jackets are very, very popular in Korea. These days, many people are concerned about environmental ethics. So in that regard, we designed a padded long jacket with less duck or goose down, but similar thermal insulations. So based on experimental result from both a thermal mannequin and human wear trials. Okay. That's all about thermal mannequin test today, and I'm going to explain a flame mannequin. As it can be inferred from the name of the mannequin, the flame mannequin facilities generate flames. The purpose of the flame test is to estimate the skin burn areas when wearing the particular PPE. So in most cases, firefighting PPE is tested in the flame mannequin facilities. So we compared the USA's, Europeans, and Korean firefighting PPE using this flame mannequin. So this photos was taken from before the flame mannequin test and right after the flame mannequin test. Now, according to an international standard, PPE is exposed to flames for just 4 seconds. So after 4 seconds, photo. So nowadays, firefighting jacket and pants, which consists of Nomex, have a very strong protection from flames. But the visor or here reflective bands and protective gloves are vulnerable to flame. So I will now introduce some results from the flame mannequin test. This table shows the Korean PPE resulted in the 2nd and 3rd degree burns on 5% only of the total body skin area, while European PPE resulted in the same burns on 19.7% of the total body skin area. So which means that the flame protective function of Korean PPE is better than European PPE. However, conversely, these results indicate that Korean PPE generate greater thermal discomfort compared to European PPE. That is, these results can give insight to PPE designers for establishing a balance between protection and comfort. The excessive discomfort can be the second dangerous risk factors for workers. One more thing about the flame mannequin. The commercially available flame mannequin in the previous slides had no sensors on the hands. This means we cannot test the flame protective function of the fires report many skin burns on their hands. So as per need, we developed a flame hand mannequin as shown here, a hand mannequin with heat flux sensors are surrounded by 8 flame throwers. Okay. Yes. So we investigated the flame retardant function of dry and wet fire protective gloves. The left two photos were taken from dry gloves after the flame mannequin test, while the right two photos were taken from wet gloves. As we can clearly see here, the dry gloves were more damaged than the wet gloves. But interestingly, the predicted skin burn areas was larger for the wet gloves than for dry gloves. So we interpreted the opposite result as being due to steam or scald burns from the hot steam suddenly evaporating from the wet gloves. So we have just arrived at the 3rd stage of the pyramid, our expertise, the human wear trials. Let me explain the human wear trials with Japanese firefighting PPE when I was at the Kyushu University. At that time, we evaluated the effect of total PPE mask on physiological strain of firefighters. At the same time, we improved the strap design of the SCBA. SCBA means self-contained breathing apparatus. So we compared a total of 4 conditions. So no SCBA conditions and heavy SCBA and old strap condition, and light SCBA and old strap condition, and light SCBA and newly designed strap conditions. These are old SCBA strap here, and these photos are the newly designed strap of SCBA. We can see the old the new straps with wider and more stable straps. So in a climate chamber, an exercise protocol was carried out for the firefighting PPE. In usual, 30-minute walking is assigned because a battle of SCBA is for only 30-minute to 40-minute respiration. So while the experimental protocol is carried out, we measure thermoregulatory, cardiovascular, and subjective responses. Okay, I will explain the recent human wear trials of PPE for healthcare workers during the COVID-19 pandemics. So in fact, the concerns about healthcare workers' PPE increased dramatically with the Ebola virus. Collapsing from heat is a real issue for doctors and nurses in the West Africa. During the COVID-19 pandemic in Korea, heat-related diseases have been increasing for healthcare workers. So you can see healthcare workers here wearing encapsulated PPE and collapsing outside because of the heat. So that this occurred in summer this year in Seoul, Korea. So we have already tested the thermal insulation of these 6 PPE ensembles using the thermal mannequin. But that is not enough to understand the physiological strain of wearers in hot and humid summer. So usually we recruit 8 to 10 subjects for human wear trials to measure body temperature. So if the main physiological parameters of the human wear trials are subject to responses, not body temperature, the total number of humans subjects should be over 30%. Number of subjects are determined according to the standard deviation of main parameters. Usually we recruit 8 subjects because our main parameters are body temperature. And we evaluated heat strain of wearers in a hot and humid environment using in a climate chamber. So as a control conditions, we tested the same wearers in a thermally neutral environment. Here 25 degrees Celsius with 50%. During a trial, we measured rectal temperature, TRE, skin temperature, TSK, heart rate, or clothing microclimate temperature or humidity, total sweat rate, local sweat rate, oxygen saturation, subjective responses, etc. So for the subjective responses, usually thermal sensation, thermal comfort, and humidity sensation are measured using particular categorical scales as shown here. And we should consider an important thing when using the categorical scales. We have our own mother tongues, and different languages have different linguistic dimensions. So if possible, we recommend using both languages, including English, as shown here, the Korean, English together. The Korean, English together, and Korean, English together. So these photos were taken during the human wear trials in the climate chamber this year. So I will explain some results from the previous human wear trials. The rectal temperature represents the body core temperature, which is an indication of hyperthermia. So we measure rectal temperature at the depth of 16 centimeters inside the rectum. The left figure at the air temperature of 25 degrees Celsius, PPE A, C, E, and F ensembles do not show any significant differences during 90-minute exposure. While at the air temperature of 33 degrees Celsius, with the air humidity of 70%, the rectal temperature went up around 39 degrees Celsius, and significant differences among 6 PPE ensembles were found. Through the data analysis, we can suggest maximal exposure time to avoid the heat-related disease of PPE workers in hot and humid environment. Plus, I'd like to introduce another human wear trials on here disposable masks. As your people in Indonesia may suffer from haze during summer. My country is severely polluted by microdust from China every spring. So in order to protect from the microdust from China, so our government developed a certification system of 3 filter labels called Korean filter, KF80, KF94, KF99. So which means these masks can filter as much as 90%, 80%, 94%, 99% of microdust of a particular size, respectively. Our concern is the respiratory strain from wearing such disposable masks during exercise. The experimental protocol consists of 3 different intensities of exercise on a treadmill, 4 kilometers per hour, 6 kilometers per hour, and 8 kilometers per hour. So we measured oxygen consumption of VO2 and VCO2 and other physiological parameters, rectal temperature, ear canal temperature, skin temperature, heart rate, blood pressure, lactic acids, and etc. while exercising, wearing masks. So as a result, we found that there was no differences in oxygen consumption of our respiration gas analysis. Also, no differences in VCO2 among the mask conditions. But for the ventilation, the VE, was greater for the KF99 mask condition during heavy exercise than for other conditions. However, we have to be careful so as not to generalize these results to others. The subject of our study were very healthy and young males, but most vulnerable people to microdust are the elderly or adolescent or patients with respiratory diseases. So we shouldn't generalize these results for the other people groups. Okay, today I'd like to move to the military uniforms. There is new but unexpected issues for researchers on military uniforms in Korea. Because the military uniforms are war supplies, so we are not able to purchase the stuffs on commercial market. We have to get permission and to lend military uniforms by the military and have to return the land at the end of our experiment. So this paper in Korea is the rental statement from the Ministry of Defense, Korea. So one important issue for military uniform is weight burden for soldiers. So this one is a full combat gear. So full combat gear in Korea weighs about 40 kilograms, as seen in this figure. So because of this excessive weight burden for soldiers, full combat gear can impair the military performance as well as comfort. In that respect, we evaluated the physiological burden for combat marching on a treadmill in order to suggest appropriate weight burdens considering individual differences in physical fitness. This slide is an example for the military experimental protocol. Unlike the firefighting PPE protocols, this protocol consists of 2 bouts of walking. That is, for the human rights trials, the experimental protocol should consider the characteristics of the corresponding real-life tasks. Okay, the last section of today of human rights trial, space suit. Okay, let's remind of the most bottom level of the research pyramid in the previous slide. There is the occupational and environmental monitoring in order to develop the space suit. We should understand the space environment first. The distinct differences between the space and the ground environment are oxygen, air pressure, and temperature. So for the survivor in space, the space suit have to be equipped with the respiration, body compression, and body temperature regulations. So furthermore, for the Mars exploration, we have to understand the environment of the Mars. So do you know how much a pair of space suit weighs? That weighs approximately 100 kilograms. Because of the gravity of the moon is about 0.16 atm, the 100 kilogram spacesuit on the Earth weighs only 16 kilogram on the moon. But the gravity of the Mars is 0.3 8 ATM. So the spacesuit on the Mars will weigh 38 kilograms. Therefore, an important mission of spacesuit developers is to reduce the total weight of the spacesuit for the Mars exploration. Plus, the heavy wind here on the Mars is another issue to be considered when developing the Mars spacesuit. So you can just imagine sandstorms by the heavy wind in desert. These items are genuine spacesuits which were worn by Neil Armstrong, the Apollo 11, who was the first astronaut stepping in the moon in 1969. The most challenging task for astronauts is an extravehicular activities. Shown here, the astronaut in this photo rides the 17 meters long robotic arms. Because most tasks during extravehicular activities are conducted by hands, the function of the gloves is more important than boots or other items. So in that regard, we tested the thermoregulatory and protective function of the NASA space suit gloves, like here. So in the left two upper portals, this long metal stuff was frozen by liquid something, and the surface temperature of this stuff was maintained at minus 18, minus 80, not 18, minus 80 degrees Celsius. So while grasping the frozen stuff, the skin temperature and skin blood flow were measured inside here sensor. So as I spoke, in the previous slide, the common keyword of my research is body temperature regulations. In the NASA space suit research, when I was at the University of Minnesota, USA, we improved the thermoregulatory function of the space suit. In usual, these suits are worn for astronauts, and such suits are called liquid cooling and warming garment, LCWG, or liquid cooling and ventilated garment, LCVC, for NASA astronaut. Among these three photos, the left photo is the currently worn NASA thermoregulator suit, and the third, the photo is the Russian thermoregulatory suit. In the middle, the blue suit is the improved thermoregulator suit by our laboratory teams in terms of the total weight and thermoregulatory functions. But the liquid cooling and warming garment, or liquid cooling and ventilating garment, the fabric construction of the NASA is shown right here. So the fabric construction is composed of 2 layers. So between the 2 layers, here the Tygon tubing is placed for circulating water. In fact, very fancy technologies for cooling or warming have been reported, but for space suit, electric or electronic technologies are avoided in order to prevent any possible accident. So this is one of the difficulties to apply new technologies to current spacesuit design improvement. Okay, today's lecture is here. From number 4, I'd like to talk about tomorrow. Okay, if you have any questions, please.
Yes, to the students who are in this Zoom meeting, if you have any questions, please either type it in the chat or you can just turn on your camera and directly speak up or raise your hand regarding the topic today, which is clothing and health, specifically about protection. Kalau pertanyaannya dalam bahasa Indonesia juga boleh disampaikan aja langsung, nanti kita coba terjemahkan kepada profesornya. All right. So while waiting for the students to come up with a question, Professor, it was a great presentation, and I can't wait for tomorrow to talk about prevention. And this is very interesting because it's a new point of view for me, particularly when we talk about clothing. Normally we talk about how it looks, but especially in our faculty, this is the first time seeing it how from this point of view of how functional something can be. And I have a question, especially when we talk about thermal, Professor, when we talk about heat. In Indonesia, it's very hot.
Yes.
Especially compared to Korea right now. I think Korea might be very cold right now. And in your slide presentation earlier, it was mentioned that comfort, the standard to achieve comfort among them, the standard is at 21 degrees Celsius. Is this something very, is this common? Or because if I was put in a room that was 21 degrees Celsius, I think I would feel very cold. Normally we live in,
Yes.
we live in a climate that's probably around 28 to 32 degrees Celsius. So is comfort something subjective depending on the environment, or is this, how do we define comfort?
Thank you for Professor Sabrina. So that is a very important topic, and also the indoor environment researchers, they are doing research on the comfort range for ethnic groups or different populations. Here, the 21 degrees Celsius is just for people who wear a business suit. So 21 degrees Celsius is not an absolute standard. And the tomorrow lectures, I'd like to introduce the thermal adaptation or thermal acclimation and thermal acclimatization. According to the habituation or thermal acclimations, the comfort range differ from the groups. So that is a very important topic, even in same ethnic groups in Korea. So according to the body physics, for example, overweight or very lean person, their comfort temperature differ from each other. So this is a very important topic for the modern society because of the air conditioning system to save energy. Also the electric car developers, because they are concerned is to save their electric energy for electric cars. So they want to set the indoor car temperature for the passengers. So to search it, the appropriate or optimal, the comfort temperature is very important. I think so.
Okay. Thank you for the
Yeah.
explanation, because I was
Yeah.
shocked to see 21 degrees. That would be very cold for me. That would be air conditioning
Yeah,
for
yeah,
me.
yeah.
That's not the normal temperature we have here in Indonesia.
I think you must enjoy the tomorrow slide for lectures. You can find the solution why differ our comfort to temperature ranges every people. Yeah.
Yes, yes, yes. Okay. Thank you for the
Is there any
explanation.
question or
Yes.
comments?
Are
Yeah.
there any questions from students or anyone here in the audience about comfort, clothing, and health?
May I ask something?
Sure, go ahead. Who is this?
Hello, I'm Eka from Materials Science and Engineering Department.
Okay.
Yeah.
Yes.
안녕하십니까, Professor. I was also graduated from Korea. So from Pohang.
Really? Thank you. Yeah.
So I was because I'm from Materials Science and Engineering Department. So I want to know which materials you use for this thermoregulation product, because I'm not following from the start honestly, but I really want to know which materials you use for this application.
The internet connection was not stable, so I didn't catch what you said the first part, but you are wondering about what kind of materials for clothing?
Yes. For thermoregulation application you use.
Actually, the thermal regulation, thermal body temperature regulations mechanisms here. So your question is about materials.
Materials.
For clothing.
Yes.
Right? So the fabric or fiber or something. Yeah, yes.
Right.
So very good questions. Let me explain using this experimental result. The main, the important factor for thermal insulation is air, still air, not materials. So when we design the cold protective clothing, the important thing is how to keep the air inside jacket or inside clothing. So when we use cotton or polyester or nylon or layers, the differences in thermal insulations is not very big, but the 2 layers or 3 layers, among the layers, if we design the air layers is greater than other cases, the thermal insulation increase. So we compared this experiment, which body part is most effective for thermal insulation, but I didn't include another result about material, but I'd like to introduce the polyester downboard and goose downboard. We compared the same design, this kind of padded jacket. So one padded jacket board inside here, another padded jacket with the goose down ball inside here. So when we measure the thermal insulation of two different materials padded jacket using a thermal mannequin, the goose down balls padded jacket's thermal insulation is slightly a bit greater than polyester padded jacket. So we recommend either one would be fine for human subject, but important thing is that the difference in front of heavy wind. So we tested no wind condition and also strong wind condition. So no wind condition, the differences between polyester downbore and goose downbore showed very, very small differences. But when there was a strong wind, the polyester downbore's padded jacket's thermal insulation is significantly lower than goose downbore padded jacket. So we think in front of heavy wind, the flexibility of downbore is greater for the goose down, natural goose down. Is okay?
Okay, thank you very much for the answer.
Yes, to be concluded, the air amount is the most important factor for thermal insulation, not the material itself. If not, the active heating system is necessary using electric energy. That's my answer.
Okay, thank you.
Thank you.
Okay, Professor, we have a raised hand in the audience. Etika Fidiarini.
Yes. Okay.
Yes.
Thank you, Ms. Sabrina. Hello, Professor Lee.
Hello.
I am Etika. I am an assistant lecturer in the interior design department in ITB as well. Actually, I am graduated from Takafumi Maeda Laboratory, Kyushu University, and we met last time at the ICPA Singapore. So it is very nice to meeting you again in this virtual seminar. And I am very interested with your presentation, especially with the one talking about the PPE for the healthcare workers, especially during this COVID-19 pandemic, which is very related to our condition now. And this is a big concern in Indonesia, since we are in a hot, humid climate for along the year. So we really have this situation, and according to your research, according to your study, the higher level of PPE shows significant increase of rectal temperature.
Yeah.
And I think that the human will feel huge of heat stress. And I would like to know your opinion. Is there a possibility to reduce their heat strain while wearing those high level of PPE clothing? For example, maybe if they were exposed to a pre-cooling condition, or maybe the use of a cold pack inside the clothing, is it possible to reduce the increase of rectal temperature or the heat strain? Thank you, Professor.
Yeah. Thank you for the very important questions. Yes, there is a solution to reduce rectal temperature. The first solution is to use active cooling system inside the PPE. For example, cooling vest or some cooling ventilation system. But that those system has a limitation of time. usually cooling vest maintains about 30 minutes or 60 minutes, and also once the cooling vest melted, that is another kind of burden, weight burden. So one solution is not possible. The several types of solutions could be considered together. So another solution is to control the time, work time, the shift. So that is not a technical solution, but administrative solutions. And also to reduce or to avoid hypothermia is to drink water enough. But for this kind of PPE workers, they have to be patient to go to the restroom because of this encapsulated PPE. So it is not appropriate for PPE workers to drink water enough. So the two solutions is that to wear active cooling system inside, and another is the shift work, so administrative controls. Yeah, that is the currently suggested solutions. Yeah.
Okay, thank you very much, Professor. Very clear explanation.
Or the thermal adaptation is another solutions.
Ah, I see.
Yeah.
Thermal adaptation. Okay, thank you, Professor Lee, for the answers.
Yeah.
Okay. Professor, we have questions in the chat. Yes.
Yeah. In the chat. Okay. Chatting.
Yes, in the chat from I think the first one is from Vanessa. From Vanessa.
Heat waves are this one.
Vanessa, would you like to convey the question directly, or maybe I should read it out? Okay. Vanessa would like to ask a question. Heat waves are quite common conditions these days, especially in Western countries or maybe subtropical countries as well. I would love to hear your opinion, if you may, about the possibilities for regular and casual clothing for daily use that supports human comforts during conditions such as heat waves. Yes, this is very lately a lot of abnormal weather.
Yeah. So the definition of heat waves differ from the countries. So the definition of heat waves in Korea differ from the definition of heat waves in Indonesia. I think so. But anyway, it depends on the characteristics of heat waves. Indonesia and in Korea and Japan, we have the hot and humid summer. But while the other Middle East areas, they have hot and dry summer. So the solution should differ from the characteristics heat waves because the high humidity, because of high humidity, the evaporation from shredding is impaired. So we have to wear the materials to have absorptive from the skin, body skin, the sweating. Fortunately, I think Shipa, my laboratory, she is going to introduce some result from her own master's experiment the day after tomorrow, especially about hijab. That should be interested. So I think the most important factor is how to manage our the body sweat from the skin.
Yes. Speaking of hot conditions, I have another question in the chat that was sent to my DM from Shafira. Shafira, would you like to convey your question directly, or should I just read it? I think I will read the question, and if she has any additions, she will perhaps type it. So the question is regarding protective clothing in the form of sun protective clothing. Is there a manual or a traditional way to ensure that clothing with certain materials can protect human skin from the sun's heat other than through cloth or standardized materials? Yes, I think this is important too, because lately, as we know, with the heat waves and everything, the sunlight, especially sun rays, has been quite a concern here in Indonesia. Is there any way, perhaps if we don't have particular clothing that is standardized, is there any way to ensure that we can protect ourselves from the sun rays?
That is not my expertise, but according to my background knowledge, so the color of the material is very important to protect from sun. For example, the black and white or reflective materials, and also the distance between the clothing and the skin is very important. For example, to protect the sun, the umbrella, the outside should be the reflective color or white, while the inside of umbrella should be the black to absorb the radiation from the sun. But if we wear the clothing near the skin, the color should be the white, not black. So that's the difference between the distance from the skin. The color is very important, I think. So, but when I was in Japan, we compared the reflective materials, the firefighting jacket, and the Nomex firefighting jacket under the partial radiation. So usually in the Fukuoka, the firefighters wear the reflective silver-like the color reflective firefighter's jacket to protect the flame and the high intensity of radiation. But when we compared the two types of firefighting jackets, unlike our expectations, when the firefighters were reflective silver type of firefighter's jacket, the physiological strain was greater for the reflective jackets. So which means so the reflective function is less than the heat accumulated inside the body. So from the research result for firefighters, the reflective material is not recommended, even though the very strong radiation heat from the flame or something. But for daily lives, from the general sunlight or sun radiation, I think the color of material is a very important factor.
All right, thank you for the explanation. Does that answer the question, Shafira? I hope so. I hope they answered the question quite fully. Okay, are there any questions, any other questions regarding protection, specifically maybe a thermal protection or a thermal regulation. So far from the audience, any more questions? So far. I actually am looking forward to, aside from, of course, your presentation tomorrow, I'm also very looking forward to Shifa's presentation because I believe there are quite few findings that are very interesting to see and very relevant to the weather here in Indonesia, which is very humid and also very hot. Yeah, about hijab. A lot of people wear hijab here in Indonesia, and we don't really think about it when it comes to temperature because it's something that we wear daily and it's very, very normal for us. But of course, it's something very unique, I think, to other people. And they think it feels, might feel uncomfortable and hot in the weather. But I'm looking forward to the research because I heard that there were very interesting findings that she has. Okay. Are there any more questions? We still have about 8 more minutes before we move into the next session. Any more questions? Maybe from any of the master degree students, maybe? Or maybe from fellow lecturers who are here as well, perhaps, if there are any questions. So, Professor, I heard there's a thermal room, a room where you can adjust the temperature and also the humidity in your lab for all the testing. And I thought that was very interesting about the facilities that you have at your lab. And how exactly how far can this room function? Because earlier you mentioned about the testing for NASA, about the astronaut gloves, that the bar could go up to minus 80 degrees, and that's very cold. And so the range of the room that's used for research, I think it's very interesting. Could you explain a little bit about that?
Yeah, okay. We have a climate chamber. Okay, looks like here. The climate chamber, our climate chambers control the air temperature from minus 20 degrees Celsius to the 50 degrees Celsius. So every 0.1 degrees Celsius, very accurate, and along with the control of air humidity over the 5 degrees Celsius. One more important thing for a climate chamber is the control airflow store. The cold store is also a kind of climate chamber, but that is not for human subject because of very strong airflow. And also usually the cold stores for food that makes noise. So high airflow and big noise are not appropriate for human air trials. So the patent for the airflow and very low level of noise. So my chamber in Korea is constructed by a Japanese company. So Fuji. Also, you can see the Kyushu University chamber here. This chamber is type of class, various type of chambers in a building. This chamber is for car experiment. This door is for car, so we can the human subject, so we can control the air temperature and humidity, the car and inside the passengers. So very huge size, but my university, we have only one climate chamber. The climate chamber is very the basic fundamental factor for human ear trials.
Great. Okay. Thank you for the explanation. I think it's very interesting that we can do trials and research by just simply changing the temperature and the humidity of a certain area, and then we can see the results of how a particular clothing can be affected, can affect humans as well in different climates and temperatures. Okay, thank you very much, Professor. I think because our time for the Q&A session has just ended. It is 4:17 now. And so I will ask for the participants to turn on their camera. So semua mahasiswa dan hadirin yang ada di sini mohon menyalakan kameranya. Professor, if you don't mind, could you stop share screen?
Okay.
Because we are going to take a screenshot together with the participants and the audience.
Yeah.
All right, so everyone in the audience, please turn on your camera so we can take a screenshot. Okay, it might take some time. Okay. Para mahasiswa mohon menyalakan kameranya. Nggak pakai background juga gak apa-apa, tapi mohon dinyalakan kameranya karena harus didokumentasikan kegiatan visiting professornya. Jadi mohon menyalakan kamera. Sekaligus jadi absen ya untuk mahasiswa mata kuliah Fashion Research. So yes, while we're waiting for everyone to turn on their camera, I would like to inform you, Professor, that this is actually also part of the course Textile Craft 1, which is the studio for fashion research. So the students here are currently looking up upon trends and latest lifestyle, whether it's pandemic related and everything, to create designs that are relevant to the way we live today. And that's why we have you here invited so they can see the latest developments when it comes to clothing and how clothing can improve or influence humans. Okay, udah nyala semua kameranya? Oke, kalau gitu kepada hostnya mohon screenshotnya siapa yang akan mengumumkan.
Saya aja.
Oke, silakan.
All right, for everyone, we'll be taking 2 shots today. Stand by for all 2 shots. The first one in 3, 2, 1. Okay. For the second one in 3, 2, 1. All right, that's all. Thank you, everyone.
All right. Okay, so thank you to Professor Juliang Lee for today's class on clothing and health about protection. And tomorrow we'll see you again at the same time at 3 Western Indonesian time, at 5 at Korean Standard Time.
Yes.
And we'll be talking about clothing and health, particularly about prevention and what you mentioned earlier about thermal regulation in more detail. So I can't wait for tomorrow. Hopefully we'll get to learn more from you, Professor. And next week we'll be hearing about more research specifically about Shifa's main theme for her main topic for her master's thesis. Looking forward to see that. And thank you everyone for joining us today, and see you later.
Tomorrow. Yeah. Thank you for your coordination and strong support of today's lecture. So see you tomorrow. Yeah.
I'll see you tomorrow. See you tomorrow.
Have a good one. Thank you.
You too. If there's anything, you can just email me if you have something. Yeah.